So the next section that we're working on deals with circles in the coordinate plane, and I have to tell you guys, circles are one of my favorite parts of geometry. So as we're going through the standards that we're working on today, our determines or derives the equation of a circle of a given center and a radius using the Pythagorean theorem. So here's the first one to memorize, kind of like when you were in Algebra 1 and you needed to memorize the y equals mx plus b equation, or you needed to memorize the quadratic formula. Remember, negative b plus or minus the square root of b squared minus 4ac over 2a. Remember? You remember it? So as we go on, this is a circle formula which you really should memorize. The equation of a circle that has its center at point hk and a radius of r fits this formula, which is x minus h squared plus y minus k squared, and that will give us the radius squared. This is called the standard form of an equation of a circle, or it's sometimes called the standard equation of a circle. It is derived from the Pythagorean theorem. If you're interested in seeing where the kind of how that worked out and how it's derived from the Pythagorean theorem, you should look on page 799 in your math textbook, and at the top it'll give you a whole rundown of how our circle equation comes from Pythagoras. Okay, so next what I want to talk to you guys about is playing with the equation of a circle, and I'm going to go ahead and use that online calculator, which is desmos.com. I'll pull it up so you can see it. Give me just one sec. So if you guys notice here, I went to my Desmos graphing site, which is www.desmos.com. It takes me to my graphing calculator. You can create an account here and sign in so you can hold on to all of your graphs if you would like. What I've done is taken that formula that we just talked about, which is that standard equation for a circle, and filled in ones for all of the variable. So you'll see that this is x minus 1 squared plus y minus 1 squared equals 1 squared. So my radius was 1, and then the point for the center of my circle, you'll see, is at 1, 1. And I wanted to kind of point that out to you so that you guys realize the difference. If I go through now and take this equation, so I'm going to copy it, I'm going to add a new equation here. And then on the second equation, I'm going to go ahead and double the size of the radius. You can see that my circle stays centered on 1, 1, because that's my h and k values, 1 and 1. Notice it's positive 1, positive 1, because the formula tells us that it's x minus h and y minus k. So the negative value, or the negative sign there, doesn't affect the value of where it's centered. So you can see it's still centered at 1, 1, except the blue circle has a radius of 2, whereas the red circle only has a radius of 1. I can go through and do the same thing. I'm sure you can predict out now that when I put in 3 for my next radius, it's going to give me a radius of 3. I can do the same again. I can even go as far to put in a radius of 4. And we might just as well do one more and put in a radius of 5. So you guys can see whatever the square root of this number over here is, or whatever number is squared there, gives us the radius of the circle. So remember, in this case, my circle, on my purple circle, would have a diameter of 10 units, which you can see it does. It goes from 6 to negative 4, which is a diameter of 10, and then that's where you get the radius from. So at the same time, if we look at these, I'm going to go ahead and turn most of those off so you don't have to see them anymore. We'll go back to my original circle that's here. If I went instead and got rid of my negative 1 on the circle, you would see that it would change the center of my circle to be centered right here at 0, 0. Because if you remember, what this really is x minus 0, y minus 0. So the center point is at 0, 0. If I took my next equation, I'm going to keep the circle in the same spot, and then I'm going to change it to be at 3, 3. And when I turn that on, you should be thinking to yourself, okay, it's going to be the same size circle. The only difference is going to be that it's going to be its center at 3, 3. So let's go ahead and turn that one on and see how it looks. And there it is. So you can see that the value that is subtracted from x and y, this is called our h and our k value, determines where the center of the circle is, and then the r value determines the radius of it. So I'm going to decide I want the same circle over here, except I want it to be at negative 3, positive 3. So I want my x to be here at negative 3, and I want my y value to be at positive 3. So I should be able to turn that on. Something went wrong. Oh. Let's try this. Well, it most certainly didn't like that. How about the opposite of 3 is 3? Oh, I see. I forgot to put this back to 1. There we go. So you can see either way I did it, I could have left that as plus 3 or minus negative 3. And it left my circle with the correct radius this time instead of the 3 squared I had there. And then, of course, it was at negative 3 for the x value and positive 3 for my y value. So at this point, you should be able to say, okay, imagine that you wanted to have a circle. Here, let me pull up a sticky note. Imagine that there was a problem that said you wanted to write the equation of a circle with a radius of 4 and a center at negative 1, 5. So you should be able to go into the equation now and say, all right, I'll start with a radius of 4. Surprisingly enough, right there gives us the right number, so 4 squared. And then its center at negative 1. So this would give it a center at positive 1. So I want that to be at negative 1. And then I also want the y value to be at 5. So I leave that at minus 5. So when I turn it on, let's check. The center should be at negative 1 and then 5. There's the center right there. And then my radius should be 4 units long, which is 1, 2, 3, 4 units long for the radius. So that should be an easy way for you guys to be able to write the equations for different circles or be able to describe a circle based on its equation. So here you can see that Desmos site does a really great job of letting you play with the equations of different circles. And then the last thing we have to end with today is the math joke of the day. That always makes me think about our standard passwords for Empower, as most of you guys know. If you have questions, please ask Miss P or I, and if you need any help on your practice pages or your homework assignment, just let us know.